Good afternoon to you all. It's a pleasure to introduce Dr. M.P. Ramnavas, who is currently working as Executive Director Design with Maharashtra Metro Rail Corporation Limited at Nagpur. He's there since September 2016. He is the overall in charge for the structural and architectural design for civil engineering infrastructure for Nagpur Metro Rail Project and other allied projects. He has over 30 years experience in metro rail industry in planning, design and construction of metro rail infrastructure like railway bridges, road over bridges, road under bridges, elevated viaduct, road cum rail bridges, metro station structures, etc. Prior to the joining of Maha Metro, he has worked for RITES, Concom Railways and Southern Railways. During his career, he was involved in the work of various important bridges on Indian Railways, including the Chenab Bridge, Bogibeel Bridge, etc. He holds his Master's in Structural Engineering MTech from IIT Madras and PhD in Structural Engineering from IIT Delhi. He has published technical papers in various international journals and has presented technical papers in conferences. He is also a fellow member of various professional institutions. With this, I leave the floor to you, Dr. Ramnavas.
Good evening, everyone here. Let me just first thank you very much, Professor Juneja, for giving me the invitation for this one and giving a gracious introduction. Let me start with the presentation now. I'll be talking on an overview of Nagpur Metro Rail Project, and I'll be taking you through the route map, the organizational structure which we are having, salient features, the stations, types, numbers, etc., the viaduct types, then launching of some of the special structures and the special spans across Indian railway tracks. We can see our map. We are having two corridors, approximately 19 kilometers, north-south and east-west. And in the north-south, the southernmost portion where we can see Capri to New Airport and Airport. That is at Capri, New Airport, and there is one more station, Airport South. This we are having on at grade station, that is at grade section, where the track is laid on the ground. And whereas once we reach the Varda Road near the airport, we'll be going on a elevated viaduct. And thereafter, it is completely elevated viaduct on the north-south corridor as well as same on the east-west corridor also. And presently, as on date, we are having 22 stations operational and about 25 kilometers. Presently, we are running the trains, and we'll be getting approval from the Commissioner of Metro Rail Safety for another 8 more stations in the coming days, for which the inspection is already over. And our organization structure of Maha Metro, for the Nagpur Metro Rail Project, we are having a managing director. Then our director project, who is in charge of all the civil engineering matters, and director rolling stock and operations, who is mostly in charge for systems and rolling stock, and director finance. And the director projects, we are having different units, planning, design, procurement, and various reaches of site execution, reach 1, reach 2, reach 3, and there is an exclusive unit for the track. I'm looking after the design portfolio. And the project organization, we have appointed one general consultants, which is a consortium of Sistra, ACOM, Aegis Rail, and RITES. And we have appointed detailed design consultants like L&T Infrastructure, INEA Architects, Shirish Patel Associates, Tandem Consultants, TUP Consultants. And similarly, contractors are Nagarjuna Construction Company, Afcons Infrastructure, ITD Cementation. Like that, various contractors are working for our project. And overall cost of the project is 8,680 crores. And viaduct will be around 40-45 per kilometer. Stations also ranging for average 40-45 crores per station. And double-decker station will be having, stations are 50-60 crores. And the double-decker viaduct portion will be around 85-90 crore cost, which that I'll be detailing further. That is double-decker. We are having a national highway also carried on the metro pillars. Salient features of the project. we are having, I already explained on the map, 20 kilometers and 17 stations plus one interchange station on the north-south corridor. The interchange station is having two sets of platform, one for north-south corridor and one for east-west corridor. So east-west corridor exclusively, we are having another 19 stations plus this interchange station. Then at Sidaburdi interchange station, we are having a place, BC junction is there called Munje Chowk, where we are having a spatial verandil type structure, which is carrying. So it is something like a building that itself is functioning as a bridge between the viaduct ends, or it can be a bridge where the building is also carried on. And we are having a double-decker, that high carrying highway and metro rail. And there is a one double-decker which is crossing the Indian Railway tracks also at one location called the Gaddigudam. Station architecture is generally on three themes, three T's: tiger, teak, and tribes, and aqua bodies. And modern interior finishes are used, and some places artwork depicting history of the region is also considered in the architectural design. And we are having differently abled friendly design for the barrier-free movement with the ramps, tactiles, etc. Then for the security, environmental design principles to reduce dead ends, corners, dark areas, all these are considered in the station design. Biodigesters are provided for eco-friendly disposal of human waste. And for tapping the natural renewable energy, solar panels are provided on the station roof. We are having rainwater harvesting, and we are aiming and getting IGBC MRTS platinum rating for all the stations. And main components of the station, which we all know, there will be, considering an elevator station, we are having an entry exit structure where the people can enter on into the metro station. And thereafter, there will be a concourse where the people, passengers will be entering through the paid area, crossing the automatic fare collection gates. And this is the concourse, and usually the concourse ideally will be kept below the platforms, and thereafter from the concourse to platform we will be having lifts, staircases, and escalators. At some places, due to certain other constraints, the concourse is not kept at the right below the platforms. That is usually the case in the case of elevator stations, but there are some occasions where we are not having that. I'll be explaining it in the coming slides. And the at-grade stations, which are shown on the depicted on the pictures here, Capri, New Airport, and Airport South, it is all at-grade stations. So concourse is not there. Both the platforms are there. It is connected through a subway or a FOB. And there are many other stations in the reach one, that is the southern quadrant of the project, southern arm of the project. We are having a station near the airport, international airport, and Ajni Square, Jayaprakash Nagar, Rahte Colony, each one having different type of architecture. And coming to one station which is called the Congress Nagar, at the road level, street level plan or road level, we are having the entry exit structure on left hand side of the alignment as well as the right hand side of the alignment, and the main station box is coming here. So ideally we should have got land for entry exit structure just opposite to the station box at this location and this location, but that rarely happens. So wherever we are getting the land, actually this land we have got from Indian Railways. There is an Ajni railway station of Indian Railways is going nearby. So this we have got the land from here, and we are having a connectivity also to the Indian Railways Ajni railway station. This metro station is named Congress Nagar station. So from the entry exit structure, we will be reaching the concourse level. Concourse level, both the entry exit structure will be reaching here. There will be a concourse unpaid area will be there. Thereafter the AFC gates, and passing through that one will reach the concourse paid area. And from that paid area through the escalators, stairs, and lifts will be going to the platform. So this is one side platform, this is the other side platform. This is the general layout of a station. And station for architecture as well as for structural requirement reasons, we are having different types of roof structure. Roof usually will be made of steel in most of the stations. And this is one station, airport station. Here we are having a concourse at this level, In this particular station, the concourse is independent of the viaduct pier. This is the viaduct over which the trains are running, and viaduct piers are there. In this particular case, this is independent of the viaduct pier, which are supported on two. The concourse is supported on two rows of piers on the edges of the road, and the roof is supported basically on that with an intermediate support on the platform, which ultimately gives the load through the pier arm to the pier. But main load supporting member is the concourse. And another station, Ujjwal Nagar. It is a double-decker station. So the station pier arm we can see, Ujjwal Nagar and Chhatrapati. It is a double-decker station where below this we are having a national highway flyover going on. And this trains are at this level, platform is here. And we are having the station roof supported on the entry-exit structure, not on the viaduct structure. Now the Jayaprakash Nagar station, again, it is having a double-decker with a national highway going below the metro level. Here we are having the station, the viaduct concrete box girder is there, station pier arms are there. And this roof is supported directly on the station pier arm. And the entry-exit structure is slightly away with a link bridge here and here. So road width will be from here to here. This speciality of this type of arrangement is that even when the station work is not completed, if the land is not available for taking up the construction, usually that happens in urban infrastructure, the land will not be available in the time when we are looking for it. So sometimes we get the delayed possession of the land happens. In that case, we can complete the viaduct along the metro alignment and the platforms as well as the station roof and commission the track without commissioning the station. So in such case, the track will there won't be any hindrance to the station to the viaduct train operation, even when that particular station is not commissioned, and we can complete the construction of that station in the later date and give entry to the platform without having any hindrance to the railway, metro train running. This is another station where a different type of roof arrangement is there, similar to the one which we have seen at airport, where it is supported on the concourse on corbels. And these are other stations in the Reach 3, where the theme is aqua, maybe the architecture type we can say as contemporary. There are different types of roofs. And this is one iconic station at 0 Mile. I think all civil engineers must be knowing this. 0 Mile is the point where the great trigonometrical survey, when they started the surveying of the country, they started marked the 0 as at a location at Nagpur. And this station is very near to that. So it is named 0 Mile. And later it was renamed as a 0 Mile Freedom Park as per the 75th year of independence. It is named 0 Mile Freedom Park, and the small park is also constructed very near to that, which we will be seeing in the subsequent slides. And the 0 Mile station, we are having total 20 stories. We are having 2 basements for parking. Then there is a ground floor. There is a mezzanine floor. There is a concourse for the passengers to come onto the station, come into the station. And thereafter, at the G+3 level, we are having the railway line, where the viaduct will be coming from this side and viaduct will be coming from this side. And after that, we are having a concrete roof and one more floor of technical room that we haven't constructed. We have constructed up to this roof only so far, and the upward 14 floors we have kept for future expansion for the property development, which usually will be given on PPP basis, public-private partnership. So this has got some opening here inside the building. So there is a verandil girder coming here also. And for this building, which is proposed to house hotel rooms in the upper floors, so that needs lesser vibration levels. So the vibration decibels which are permitted for hotel rooms is 72 VDB. So we have conducted a vibration analysis for this structure, and we have found that it is more than 85. So we have to bring it down. For bringing it down, there are many options. Different types of rail fixtures are there. Then spring, instead of spring, there is a rubber pad can also be installed. There are various means, and this is one of the most efficient thing which will bring down the vibration VDB by about 14 PDB level will be brought down by 14. So we have introduced this thing, that is floating track supported on springs. So this is the structural slab we are having. On the structural slab, this slab will be cast with a spring inbuilt. A space will be provided for the spring, and the spring will be connected later on to that. And this floating slab will be literally floating on these springs, and track will be laid on that. So naturally there will be little more deflection than the normal track. So all these analysis we have done and ensure that it is within limit. And this is some pictures of the 0 Mile station, which is renamed as 0 Mile Freedom Park. A small park is also annexed to the station building. Now we are having the interchange station at Sidabodi. So this is the east-west corridor alignment, and this is the north-south corridor alignment. This is the southern part, this is the eastern part. So this is the exterior view, another exterior view. And this is that Munjek Chowk location where we wanted to make it pillarless. So about 40 meter by 21 meters, we are having 4 corners supporting the verandil structure. So here this is the street level. Then the upper level, that is concourse level for the north-south platform is there. This is the concourse level for the north-south platform. Over that, on the verandil girder, we are having the track. Then again, the verandil is going up and closed at this level. That level, on the east-west, we are having the track for the east-west corridor. And over that, we have provided steel roof with some ornamental finishes are also proposed, which is yet to be taken up. But with the roof and all other facilities, station is commissioned. So this is another under construction, same station, east-west corridor, north-south corridor. Here is the southern part. This is the northern part. And this is that Munji Chowk location, 4 corners of that verandil structure is there. And after that, the roof is also laid. It is the photo is incomplete photo, but the work is completed already. And here we can see the north-south corridor is going, and it is crossing. There is one Govari flyover here. There is a road below and there is a flyover. So this is one of our elevated viaduct is going and crossing the Govari flyover here. And this east-west corridor is going and crossing the same flyover at another location. And here a mall is coming up, a private mall, and we are giving connectivity to the mall. So the passengers can go directly, they can exit from the stations towards the mall, or the mall customers, after their shopping, they can come into the station through access facilities which we'll be providing at the interface. And we have adopted sustainability measures in the stations like rainwater harvesting, biodigester, etc. So even for the station building, as well as from the viaduct, we are having collecting the rainwater, and that will be through pipes. It will be taken through the piers, and it will be taken to the rainwater harvesting pits. So that way we are recharging the groundwater. And we are having biodigester, which is a technology patented by Defense Research and Design Establishment under DRDO. That has the advantage of no energy and zero sludge generation. So it is using anaerobic bacteria, anaerobic microbial inoculum, that is the name of the bacteria which is used. So once it is charged, it will keep on working without any hindrance. And we are having the biodigester tank, and after the treatment, it will come on to reed bed, where the reed bed, the roots will be there. It will further improve the quality of the water. Then filtration, rapid sand filter, and disinfection is also done. Then thereafter, it will connect it to the collection sump, and again used for flushing toilets or for horticulture reasons wherever we are having landscaping. So we are having dual plumbing system in our station buildings to reuse the treated water also, and also for the fresh water. And this is the installed facility of the biodigester tank. This is FRP tank, 5 kiloliter or 10 kiloliter, like that. FRP tank is embedded in the ground, and the water after the treatment, it will come to the reed bed, and there is some plantation here and below, and there will be diffuser pipes inside this, and that will come out, and that will be taken to the rapid sand filter and further disinfection, etc., and for storage. And this is the FRP tank, which is about 2 meter diameter and 3.5 meter length. This is for 5 kiloliter, and the other 10 kiloliter, the size will increase, and that will have a lot of baffle valves inside to increase the flow time. So again, a schematic diagram for that. Clear water will be coming from the underground water tank. It will go up and it will be coming for urinals, etc. And the sewage will be coming to biodigester. Final treatment, it will go back to this treatment effluent tank. And construction waste management also, we are taking all care for that. Excess soil generated is reused for landscaping or backfilling. Garbage, recyclable waste, biodegradable waste, and hazardous waste, it is divided and accordingly disposed with the scrap vendors or according to the type of waste which we are having. And the sewage generated is even in our depots, all buildings, even our administrative Metro Bhavan building also, we are having biodigesters installed for treatment of the sewage. And construction and demolition waste is stored in designated locations for further disposal. That is how it is being done. This is supplementary cementitious materials are used in concrete, fly ash, ground granulated blast furnace slag, or microsilica according to the proportion. Generally for PSC structures, we are not using any of these things, so to avoid lesser hardening of the concrete. And we are also tapping solar energy. Our phase 1 project, which is now getting completed, the requirement will be 30 million units per year. So our aim is to have 2/3, that is 65% of the total energy, including traction requirement, to be met by solar, that is 20 million. Once we install 14 megawatt peak equivalent of solar panels, but due to some land issues, we are yet to reach that level. So it is in the intermediate stage now. Now solar panels we have installed on the airport metro station and airport south station, which we can see on the roof. New airport station, Capri metro station, wherever the slope is compatible for the solar panel installation, where we have installed that. And for the air pollution control construction phase, maybe we are using the sprinkling water sprinkling is being done. Dust collector in the hopper we are keeping by covering it with that cloth. Then back filter is used wherever cement is brought through the truck is filled into the silo. And conveyor belt is also provided cover in the batching plant location. Water sprinkling is done. Physical barriers are provided wherever required. We are also doing afforestation for compensatory purpose. We have developed 2 area, 24 acre and 52 acre pieces of land which we got. 6,500 and 11,000 number of trees have already been planted so far. Now coming to the viaduct, which is the backbone of the metro system. We generally adopt a PSC box type superstructure, except in obligatory locations where we are having steel eye girders as composite structure, or concrete, precious concrete eye girders, or any special railway crossing, we are having different type of structure. And PSC box type, we are using precast segmental construction through launching girders. These are launched. We'll be seeing those things in the subsequent slides. And we generally adopted 1,200 dia pile foundation. And at some location where shallower depth we are having very good safe bearing capacity, then we have gone for open foundations. Generally all piers are of single column, except few locations it is portal. And we are having some double decker stretches about 3.1 kilometers in reach one, that is the southern part of the project, and the northern part reach to Kamptee Road. We are having about 5.5 kilometer double decker carrying 4-lane NH at the bottom level and two-line metro rail at the top. And in the double decker stretches, this is what I was telling, is there is ideally below the platform we need to have a level where the concourse is provided for the passengers to assemble and take their to further go to the respective platforms, or to assemble from the platform coming and then take which side they have to go off the road. In double decker stretches, this position where we are supposed to keep the concourse is already occupied by the national highway flyover. So we are having a split concourse on the roadside structure, which side structures we can say. So side structures, we are having half concourse there and half concourse on the other side. And in the same structure, the passengers coming from the road level, they will enter the side structure. They will go further up to NH level. Then further up NH level, they will have the concourse. There will be an intermediate level. Sometimes if there is a height, further height is available, which we may use for technical rooms, accommodating technical rooms, or for accommodating some property, business spaces, running some kiosk, etc. Then further, they will go to a interchange level, where at the utilizing the height of the superstructure of metro viaduct, we will keep a bridge to cross this location. We'll be seeing that in the subsequent slides. And generally for the pile cap, pier, etc., we have used to concrete of grade M35 to M60, and steel structural steel used is generally E350 grade, which is a high strength steel, and reinforcement steel uses Fe500D. And the segmental box girder used in general in all other metro projects till recently is a box girder, which is again segmental, and all these segments will be cast, and then finally through the launching girder it will be launched and stressed. After that, another precast element for the parapet will be brought from the casting yard, and this will be attached with the deck slab of the piers, this box girder, through stitch concreting both sides. This is how it is generally done, starting from Delhi Metro and even Bangalore Metro or other metros also. So we have made some change in this. We have made our cross section with the deck slab and the box girder like this. And the parapet, instead of having a separate parapet, we have made the parapet a smaller one, integral with the box girder. And it is cast integral with the box segments. So with that additional effort of casting a parapet and bringing it to site and launching it above the running traffic of roadway traffic, that is avoided, which has enhanced the safety aspects as well as the cost and time aspects. So this was possible, and with this we could make the width of our viaduct to 8.5 meters instead of 9.95 generally used with the other earlier type of conventional arrangement. By integrating this thing, we have got reduced girder weight, superimposed dead load is also reduced, erection of precast is avoided, there is no activity like that, stitching activity is not there, reduction in time and cost of construction. And dimensional aspect may generally for the conventional, the inner distance between two tracks will be 4.15 to 4.25 in the case of box girder with the conventional arrangement, and in the U girder it is still more. We have adopted 4.1. Then height we have reduced to 0.7 meters compared to 1.2 elsewhere. Another feature which we are having here is we are in the operational aspect of the trains. In case of an emergency, when a train is required to be stopped in between and the passengers are to be evacuated, what was generally being followed earlier is side evacuation. The side doors of the train will be open and people will come out of the train, and they need a walkway on the sides. Along the walkway, they will walk down to the nearest station. This is how it is being done generally. But in our case, we are having front and rear evacuation. If a train is in any case held up in between the stations on a viaduct, then the front and rear doors will be open, and coach by coach people will be evacuated, and they will come out of the train at the end of the train or at the front of the train, and they will be walking along the viaduct in between two rails of the track. So there is a space between two rail plinth. So because of that, we don't have the need of having a side walkway. So that is one reason we could make it possible to do away with that parapet, precast parapet. So, and we have made a little more compactness by avoiding cable trays and keeping all the cables on J hangers on the parapets. With that, we could save, for a typical 25-meter span, we could save some 30 cubic meter of concrete in the cross-sectional dimension of the superstructure itself, and which ultimately will reduce the dead weight, etc. And it will help in reducing the cost of the substructure and foundations. So overall cost reduction due to this compactness and integral parapet casting, it is estimated to have a saving of about 100 crores in the total project. This is how the conventional box girder segment with the deck slab is cast, and this is the parapet casting. So this is including the shuttering only. I'm having a photograph. Now it is not being used in our project. Whereas in our case, the box girder section is cast along with the parapet. And that will be used here using launching girder. And this cable tray arrangement, etc. Here we can see in the case of conventional, these are two rails of the track, and there are two rails of the track here. And these yellow colored are for the traction 750 volt traction, where there is a third rail is provided to provide the traction power to the trains. Whereas we are having overhead electric equipment, so this requirement is not there. What we have changed from this is this cable trough is not provided, and this parapet there is no walkway required, and this J hangers we made it in one more layer. So the cable trough, instead of cable trough, all the cables are carried on the J hangers at the sides of the parapet. That can be seen here. We are having overhead traction, overhead portals for the traction. This is made of tubular. That is first of its kind in India. It is economical compared to normal type of latticed portal or whatever things which we generally use on Indian Railways or elsewhere. And here we don't have a side walkway, whereas the parapet, and then we are having a stainless steel handrails. And here we are having all the cables taken on the side of the parapet. Now coming to the geology and the foundation aspect of the project, we are having 4 reaches, and the reach 1, that is the southern part, we are having hard basaltic rock with the depth varying from 15 to 25 meters. And at some places we are having weathered rock at a shallow depth. So we went for open foundation in very few locations, generally pile foundation with a 750 ton. And the northern part, we are having highly weathered granitic gneiss along with schist. So that is very poor kind of soil. So we cannot have an end bearing. So we have gone for friction piles with a depth ranging from 20 meters to 30 meters. And the capacity restricted to 650 ton. And in western part that we call as reach 3, we are having basalt rock. So there are many more number of open foundations are provided there. And at some locations, we have gone for pile foundation also. And reach 4, we are having reasonably low, deep, shallow level. Maybe we are having hard rock. So up to 750, we have gone with the friction cum and bearing piles. And for the interchange station, Sidaburdi, we are having 750 ton capacity. The hard granitic gneiss rock is available, and 15 to 18 meters below the cutoff level, we have founded the rock. And initial vertical load test is done with the cantilever loading or with reaction anchors. And cantilever loading, especially when we want to do it on road, it may need more time, and also some safety hazard is also there. So reaction anchor type is more preferred nowadays. Typical elevation of the concentric pier for the one level, that is single decker. We are having transverse spacing of the bearing as 2.6 and longitudinal space between bearing for 2 spans as 2 meters. And this is approximately 1.5 by 2 meter pier size or cast in situ pier. And at very few locations, we are having portals. This is near Airport South. And these are some of the under construction photographs from site. Here, the single decker viaduct superstructure and the launching girder can be seen. And here we are having it is a ramp portion for the double decker portion. So this pier caps are for the NH level flyover, which we'll be seeing further. And the metro level will be at this height. So for the launching of the superstructure, generally we use launching girder, which are little above 2 span length, and the maximum span we are using is 37 meters so far used, and mostly restricted to 34 meters. So this will have one front support, middle support, rear support, and rear trolley. These two spans are already erected. So this is a new span going to be erected. On the erected span, this is already auto-launched spanning between the two other piers where the girder is to be erected. So the front support will be on the pier which is standing alone, and middle support will be on the pier where the superstructure is already erected, and there will be a rear support and a rear trolley. These are the sliding beams which will be taken here, and it will be lifting the segments brought from the casting yard one by one, and it will be hung like this. Once all the segments have reached, then it will be aligned properly. Then temporary pre-stressing will be done between two segments, all pairs of two segments. Temporary pre-stressing will be done. Before that, epoxy will be smeared on the joints, and temporary pre-stressing will be done on top and bottom. So the epoxy also will get squeezed and gets filled into the entire contact area of the two segments, where we are having some shear keys also. And all these segments are match cast at the casting yard, so as to have proper housing of the that is interfaces. And the time after that, pre-stressing strands, so cables will be threaded into the ducts left during the casting, and that will be stressed and grouted. The cycle requires about 5 days for one span, average. Now we are having, as I told earlier, in the southern part we are having about 3.1 kilometer, having 3 stations in the double-decker look, where we are having a highway also being carried on the metro piers, and here again 5.5 kilometer. So the challenge for having two types of loading is that so many load combinations are to be considered in the design. So live load we have to consider as per the IRC class A, which is 4-lane loading. So each 2-lane up and down sections, and 70R wheeled also. Live load of metro 16-ton loading is considered, and braking and tractive effort, then metro rail LWR forces, then centrifugal forces wherever curve is coming, and all the combinations as stipulated in IRC as well as IRS. Then in this double-decker location, for the reach one, we have restricted our pile capacity to 600 ton, and SPC, whatever we have considered maximum is 50. Even if it was more than 50, we considered only 50 to be on the conservative side. And the superstructure, we are having 3 locations where this NH flyover is carried on metro pier. 2 locations metro is constructing for NH, and 1 location NH is constructing a flyover. So our metro pier superstructure is metro superstructure, and also the pier starting from the highway flyover level is constructed by metro. That comes in the reach 4 Prajapati area. So wherever complete construction is done by us, we are having the NH flyover with us, that is designed as a spine and rib arrangement. And in that location, as I told earlier, concourses will be there. So it will be considered as a split concourse on both sides and connected by a link bridge. So this is a typical span of double-decker flyover where the pier will be there, and pier dimension reduces after the highway level further to the metro level. And highway level, we are having the flyover with the spine about 6.25 top width. Spine is there. Again, it is precast, segmental construction, and ribs are T sections, which are also precast, and it is joined and stitched later and pre-stressed. And the dimensions of the pier from street level to highway level will be larger. Then highway level to metro level will be smaller, taking only the metro loading. Here, since the height is more, we have considered the UIC provision for the track geometry also. So the lateral deflections are limited, are checked to have no impact on the railway alignment, which is provided in the UIC 776.3. There is some problem in the Microsoft Point is not responding.
Okay, it's now moved, I think.
Yeah, I think it's okay now. Yeah, it's okay now. I'll continue. This is again a cross section of the double decker where the NH level and metro level box girder, NH level spine and rib can be seen. By providing the spine and rib type of superstructure, we are having more vertical clearance available here. So the road level is raised to the minimum. But in this case, which is followed by the construction taken up by National Highway in the eastern side, Prajapati, they are having a pier arm. So the vertical clearance is to be maintained 5.5 meter here, and they are having two independent box girders. And this metro pier will be started from this level going up, and metro box girders are installed by us. So this is another type of section used in the other part, which is not basically constructed by us except this portion. This shows the cross-sectional dimension wherever we don't have a metro station. Non-station portion, 2 meter by 2.5 is the dimension of at the bottom, and top 1.5 by 2 meter. Whereas the station is there, then station pier arm will be there, which is holding the platform, and in some cases the roof also. So in such a case, this pier column dimension is increased from 1.5 to 2. It is increased to 1.7 to 2.2, 1.7 by 2.2, and here it is 2 meter by 2.5 is increased to 3 meter by 2.5. And one complex thing which we are having in the case of double decker type structure where we are having a station is there is an interchange to be provided between the two parts of the station which are on the either edges of the road. So what we have done is from the road level here, this is the national highway level flyover level pier cap where the spine will be kept. Then it comes here, we have kept a extended pier arm and another component. These are all integrally cast but in different stages. So this is along the direction of the metro alignment. Then we will have this pier arm, and this top slab will be kept spanning across the pier arm, and we will get the space here like a tunnel once this is completed, which is part of the link bridge. So from the one side of the station, we will provide a link bridge up to this. Then we will go through this, cutting across the metro box girder and go to the other side. This is how the interchange is happening. It is not only for the design, for the construction also, it is very complex. So in the phase 2, if such a situation comes, we will try to avoid that. It's not that easy. This is how it is. This is that pier arm. This is the top slab kept, and from here to here is the conventional box girders coming, and this is the hollow space, tunnel kind of space created onto which the link bridge will be connected on both sides. Here also it is visible, a small gap we are having with a different type of superstructure. So this is one middle pier of the station will be having this interchange arrangement. Other piers will not be having interchange arrangement, but that will be having a pier arm to support the platform also. So heavier load, and hence that particular station piers are of a larger dimension. This is a typical station pier arm, not an interchange location. This is again typical spine and rib precast cantilever arm as a rib. This is the spine cross section, and here is the rib. This is all separated. So this is how it is precast, brought to site, erected, pre-stressed, and after that this will be joined here, this will be joined here, and pre-stressing stitch concrete will be done from rib to spine, and rib to rib. There will be another rib here, that is also stitch concrete is done. Then thereafter the pre-stressing stands will be provided through this for the entire width, it will be pre-stressed. And this is when we started reach 1, that is the southern side. From that, whatever we learned from the reach 2, when we reached, we have made this stitch concreting, that precast itself, we provided a bottom shuttering kind of portion, so that there is no further shuttering required except a very small strip of metallic strip. So the stitch concreting shuttering was becoming simple. This is provided in the northern part of our this thing, which is taken up later. Now it is almost nearing completion. And this is how the erection methodology for a 2-level or double-decker kind of superstructure viaduct. Here, the separate launching girder is used, and the launching girder will be auto-launched onto the span where it is to be launched. And through the truck, the spine segments will be brought. It will be hung here from the slider beams sliding on the launching girder. Then after that, it will be aligned and it will be stressed. Once that stressing and grouting is over, then we will start the erection of the metro level girder. For that, it will be, instead of taking it from the down, since this presence of the spine girder will not permit that, so it will be like a front feeding. So the truck will be brought at the front front of the span which is to be erected, and from there it will be taken, tilting it 90 degree, not in the alignment where it is to be erected, but tilting it 90 degree, it will be brought up, and front leg has got 2 legs, and in between the legs there is space for this segment of 3 meter maximum length to go across. So it will come through the space between 2 legs of the front support, and it will come here and it will be aligned like this. And after all the segments are aligned properly, then it will be pre-stressed and grouted. That is how it is completed. And this is one particular case where we were having, because of presence of a nulla here, there is a pier P42 and P43. We needed to provide longer pier cap, extended pier cap. The idea was that the metro level box girder used generally on metro is a 2 meter depth. So 2 meter depth can maximum use up to 37 meter, preferably up to 36 meters span, center to center of pier. In our case, since this is there, the span is more than that. To reduce the span of the superstructure, we have extended the pier cap for both sides, and accordingly this thing is done. So when in that case, when extended pier cap, either we have to fill the top of the pier cap for a 2 meter height with nominal reinforcement and concrete, or we have to provide a superstructure. In our case, it is about 6 meters. So we have provided 2 bearings here and a superstructure that is again of segmental type. 3 segments of box girder is kept, and it was pre-stressed. So that is also done in this launching scheme. It can be seen in the this slide. So here it is, 3 more segments are brought here, and it was pre-stressed here. After that, the launching girder will move here, and this span will be completed. And in the case of NH level, this arrangement was done with in situ concreting, not a precast element. And in the case of double-decker 2-level superstructure launching, it takes usually average 9 days. And this is how the double-decker launching was going on. The spine segments for the NH level was being lifted up. It was being lifted up here. It is kept hanging. And after that is completed, the metro level segments are being lifted, and it will be kept here, and further it will be stressed. Then launching girder will move out to the next span, and again spine, NH flyover level and spine, and then metro level box. And this is some photographs showing these activities. This is one spine is completed at the NH level. The metro level is going to be taken up. Here, this is the station portion where the double-decker alignment is there. So we are having the NH level spine is there. Ribs are yet to be attached to that. And these are the station pier. At the central pier, we are having the link bridge. For that, the provision is being made with an extended pier cap and some arrangement for the pier arms. And this pedestal kind of thing on the pier arm is for supporting the platform, for making up the height between rail level to platform. And this is how the ribs are being installed. That steel formwork, steel structural assembly will be kept here, and below that each rib will be lifted up, and that will be kept here, and stitch concreting will be done. After that, stressing will be done. And this is the shuttering required for stitch concreting between two. This is the gap available, and this is the shuttering kept. And in this kind of design, we need a very small strip of steel shuttering with this arrangement. And this is a after erecting the, it is slightly dark in the picture, after erecting the ribs onto the spine. Other spans it was not completed. And this is the final bottom of the spine, spine here and the ribs. And this kind of superstructure is available on Mumbai International Airport much earlier. And this is again that 2-level launching is being done. And to speed up the work, we generally have launching at 2-3 locations with the help of 2-3 launches will be working, launching girders. So it is coming to a closure here. And this is after finishing, metro train is running on that. And these are some photographs at night for the NH level and the metro. Metro level, there is no light seen. This is again Chhatrapati, Jayaprakash Nagar station, where the station can be seen. Metro level, train is running, and this is the highway level. Now we are having few special spans. One is across the railway tracks, basically, where we don't have much control on organizing the pier locations or adjusting the spans. So in this location called Anand Talkies, we are having 5 existing Indian railway tracks. There are 5 tracks, and they are having a proposal for future 3 more tracks, the 2 on one side and 1 more other. So totally we have to give space for 8 tracks, and our alignment is crossing at a skew angle of a 52 degree. So the actual crossing, if it had been square, would have been 45 or 50 meters, but because of the skew angle, larger skew angle which we are having, the length of the span required for crossing is close to 100 meters. Finally, we restricted to 97 meters. So in that location, we are having an integral bridge constructed using balance cantilever construction methodology, which is having a span configuration of 72 plus 97 plus 62.2. 62.2, it is slightly on a transition curve also. Mild curvature is also there. We are having another location where at present we are having 2 Indian railway tracks, and they are having a proposal for 4 more tracks. So totally 6 tracks we have to accommodate. For that, our crossing is at 18 degrees skew. So we were able to manage it with 80 meters. But there again, another feature is that 80 meters span, it is part of a double-decker stretch of 5.5 meters. So we have to carry the 4-lane NH also at one level, and the upper level we have to carry the metro 2-lane metro tracks also. And we are having another Southeast Central Railway track where a 36 meter simply supported steel concrete composite structure railway crossing is there. We are having another flyover built for the national highway connecting to our double-decker near the airport. So that has got a bowstring girder, which is a RDSO drawing which we have followed. That is 63.4 meters. These are the 4 railway crossings which we are having. And this is the Anand Talkies where balance cantilever is constructed 72 meters plus 97 meters plus 62 meters. And this is coming to that heart of the city, and this is the Prajavati side. And here the one question would have been why we needed a skew crossing, because considering various other aspects, if we follow an alignment to cross it to more or less a square, cross the Indian railway track more or less square following this, we cannot have a sufficiently flatter radius here is one point. Second is there was no chance of getting land here, and even this alignment may go to a different locations, whereas we have to bring it to closer to the Nagpur railway station. So that is why in the detailed project report time itself, this alignment was kept at a 52 degree. Initially we proposed a steel truss also here, but there was no space for fabricating and launching the steel truss. So that is ultimately made us to decide having a this thing, concrete bridge with the balance cantilever construction. So this is the longitudinal section, that's 72 meters. This is one pier is there, then again 97 meters, 62.2. And this is the plan. These are the existing 5 tracks in black and 2 + 1, 3 tracks in green. This is on a 52-degree skew angle. And this is a typical half portion of the structure. We'll be seeing some more drawings to show the sequence of casting of these things. Usually the balance cantilever construction will be taken up starting from the pier. This is, we are having totally 3 spans integral bridge. So middle 2 piers we are starting with a with the pier head of 16 meters, 8 + 8, 16 meters. Then using form traveler, this is the railway location. Using form traveler, we will cast another 3 meters here, another 3 meters here, which will be balanced. Similarly, on this pier also 3 meters, 3 meters. Like that, both the piers incrementally will be grown with the concrete 3 meter in 3 meter intervals. So 8 meters plus then 39 meters on this side and 39 meters. That is again 13 segments of 3 meter when we complete. These two will come closer to each other, leaving a gap of 3 meters. So with that 3 meter, we'll be closing here. In between each stage, after each segment casting is over, we will wait for the concrete to harden for 5 days. Then we will do the stressing. Then grouting and the form traveler will be moved to the next segment. So when the work is taken up, the entire duration of the work will be from railway. We request them and the railway will impose a speed restriction for the entire duration of the work. And during the movement of the form traveler, that usually will be taking up in midnight. There we will be taking a 1.5 hours traffic and power block of Indian Railways, and this form traveler will be moved. And during movement only, they were insisting for that. And after once the movement is over, during concreting, we were not taking any block. So even if train is running at a slower speed, there was no hazard. We were having a very reliable system in place. So hence we could continue with that. So once these two are coming closer with a 3 meter gap, so each segment, after adding each segment, we will be threading the cables and doing the pre-stressing. And once it reaches here, then the continuous cables also will be kept here after the casting and hardening of this. Then both the ends will be having ground supported staging, this side and this side. And this in situ casting of this superstructure will be done here. And the superstructure has a depth of 7.25 meter here and 3 meter here. And here also 3 meters. So this will be done. After that, again, the final pre-stressing will be done according to the design stages. And this is the form traveler arrangement. And this is the pier legs and this is the pier head. And this is one form, say one set. So half will be here and half will be here. The form traveler should be able to carry a weight of the concrete, wet concrete plus all constructional loads for a length of 3 meter and depth varying from 7.25 at the start to 3 meter at the end. And this is some pictures during the various stages of construction. Here we are having the pier, and it is being constructed on balance cantilever using balance cantilever method and both sides. And it is further going, and it is almost meeting here, and the closure is done, and final pre-stressing is also done. And this is load testing is also, this is only a 3D view, but finally the load testing is also done on this bridge. And we are awaiting the Commissioner of Metro Railway Safety sanction for operation of traffic, passenger traffic. And this is another location called Gaddigudam, where we are having a double-decker railway crossing, which is part of the 5.5 meter long double-decker stretch where 4-lane NH and 2-lane metro is there. So here already NH is going as a subway below the Indian Railway track. Indian Railway track, earlier they were having a plate girder bridge. Now later they have changed it to pre-stressed slab, pre-stressed concrete slab. precast precious concrete slabs. So now that slab is available, and this is a plan. There are two Indian Railway tracks, and this is coming from the northern side towards the city. So we have kept a span of 80 meters. We are having many obligatory situations, like here is a Gurudwara, and we cannot have the pier closer to that, encroaching into their land. And railway always wants the pier to be kept outside railway boundary. So this side we have gone a little away, and this side railway allowed us to provide it inside the railway boundary. So the span center of pier to center of pier is 80 meter, and this is the longitude elevation, we can say, for that span. So this is the 80 meter span, which is of a N-type truss. And on the approaches, we are having the spine for the NH level continuing, spine and rib continuing. And top level, it is pre-stressed segmental box for metro was supposed to be continued, but due to some construction sequencing, because since this is taking time to complete, now we are just completing it. In few days, everything will be over, including the deck slab casting. So to speed up the work, if we wait, we cannot wait the launching girder here to complete this work. So launching girder had to be demobilized. So we have converted this span at metro level to steel concrete composite with steel eye girders and concrete slab. Similarly, on the other side also. This is on a 18 degree skew with a 80 meter span. NH is at the lower chord level. Here we can see 2 existing track and 2 + 2, 4 proposed future tracks for Indian Railway. And this is the cross section of the truss, where we are having the top member, top chord, bottom chord, top chord. And this is the cross girder, which has built up I section. Then NH deck level is there, 4 lane, 2 lane + 2 lane. Then we are having cross girder at the metro level, which is a truss type to have more stiffness, lateral stiffness. And we are having the deck slab for the metro level, and metro overhead equipment will be there, overhead electric equipment. And this is the portal. Here actually just to meet some of the provisions which the railway was having in 2017-18. That time we were getting this general arrangement drawing approved. They wanted redundancy to be built in for the structure in case an Indian Railway train gets derailed. This structure should not, further secondary failure of another bridge should not happen. So in the case of Anand Talkies balance cantilever, we have provided a fending wall, RCC wall, fending wall designed for whatever force stipulated by railway around the pier, around the balance cantilever supporting piers. So here what we have provided, the portal we are having, we have introduced one more redundant leg. So even in any case this gets crashed or failed, the portal will remain without that. So that was a redundancy done. But after 1 year of issuing that circular, railway themselves have kept it in abeyance. It has not been followed now. But since our GAD was approved like this, so we are continuing with our same kind of work. This again, the grade of steel used is E350. Generally, E350 is used for the truss members, and the fatigue critical stringers and cross girders need not be of E350. It can be of E250 also. But to have uniformity in the procurement of material and usage to avoid any confusion, and also the cost between E350 and E250 when you are ordering in, when we are ordering in bulk is not much. So that is one reason that E350 for followed for entire thing. And the truss width is 18.9 overall. Center to center is 17.9. 18 meters is center to center, and overall width outer to outer is 18.9, holding 4 lane of NH here, and height is 13 meters overall height. And here the bearing arrangement provided, we are having 4 supports to that 4 supports, 4 corners. This is the 80 meter span. 4 corners we have provided vertical bearings, and a pin bearing was provided here at one location to take the longitudinal forces, and a longitudinal guide was provided on the other side. At the construction stages, this will be the finished truss. So construction stages after the truss erection. Also, I have something to detail in the coming slides. After the truss is erected, the construction stage is that the NH level slab will be done. After that, metro level slab will be done. That is how the construction stage is given. Now the launching scheme across the Indian railway track. Various schemes were studied for the last many years. Initially, we thought of having the entire thing erected at the adjacent span, just before the particular span. So 80-meter adjacent span, we need to have 18.9 meter wide width with whatever clearances in the straight alignment, so that we can fabricate and erect it there. Then it can be pushed through nose launching or whatever means. But the road alignment is not straight, and the shops nearby, which we thought of getting demolished and acquiring, which did not happen. So we had to devise some other methodology. So finally, the methodology adopted is the total length of 80 meter span, which has got 8 panels, was divided into 3 parts. So there was a part 1, we'll be seeing that. So for that purpose, the launching scheme was devised with a lot of temporary supports made of steel tubular columns, and a bridging beam was given. These are the temporary supports. That itself was a huge work. You can see the longitudinal section, temporary supports for that, concreting, even piling, everything was done. After it reached the proper level, then we have provided the steel built up girders on both the approaches, and this is across the railway, which is to be spanned. For that purpose, we have taken traffic and power block from railway, and through crane, that girders were installed here, erected here, planway here and here. It is in skew actually. So this was later made very stiff to avoid any unequal deflections between two lines of the same truss going while moving. So this is for bridging between the temporary piers on both sides of the Indian railway track. Then so now this is made, and the top we got a surface properly. After that, part 1 is erected on supports which are placed on jacks to adjust the levels for the proper fabrication and connection. So after this part 1, part 2, which was supposed to come here, if you see the node numbers, we are having L1 to L9 for 8 panels. So 7, 8, 9 was part 1 initially erected at the location where it is to be kept, but at a higher level, because the clearance is required for providing this temporary structure. So this was kept at a 3.5 meter above the final position, which is yet to be lowered now. So this is made. After that, another 3 panel length, approximately 30 meters, that is erected here, of 18.9 meter width, 30 meter length, 18.9 meter width, and 13 meter height. So this is made here, and keeping on Hillman rollers, and through pulling rope, this was pulled to this location, and later these were connected here. So part 1 and part 2 were connected. After that, part 3, that is node number 1, 2, 3, connected to 4, member by member. So now this work is over. After that, these girders are also removed, and yesterday midnight, these girders are removed from the span through cranes. So now this girder is supported on four corners on temporary staging. It is to be lowered down now. So this is a 3D view of the finished structure, where the Indian railway track will be below. That subway will be below, lowermost will be subway, then Indian railway track, then the highway flyover, and the metro level. So totally 4 levels of transport, 4-level transport system. Ultimately, this will become. Our structure is catering to 2-level of the transport system. Some site photographs of the truss fabrication and erection. Generally, submerged arc welding is used as much as possible. And these are all built up sections, and HSFG bolts are used for joining it at site. and totally around 78,000 HSFG bolts are there. And this is some fabrication and erection and the trial assembly being done at the workshop in Butibori. After that, it was deassembled and transported to the site and reassembled here. So this again trial assembly, and the pre-camber checking was also done at the trial assembly. After that, deassembly, aluminum paint was applied, metallization, painting, etc. Then it is brought to the site, and site it was progressively being erected. This is lower chord, lower joint. This is how those things are, and this is the final truss is also completed. Now we are having a Prajapati railway crossing. That is a simple structure with a 36-meter railway span. Railway track is there. We are having 2 piers here connected with the steel eye girders and composite slab. Here, due to utilities, presence of utilities, we had to orient our foundation in a very unique way. That is available in almost all urban construction nowadays, because every time when we dig, we get some surprise of having some utility which is not able to be shifted. So we have to find engineering solution for such situations. This is how the superstructure of that. Now we are having a boosting girder that is for a highway flyover which we have constructed, 63.4 meter boosting girder. This is RDSO drawing we have used. This is the completed work. Another photo. And we are having 2 depots. One is at Mihan. Mihan, I think everyone knows, multimodal international cargo hub and airport of Nagpur, at Nagpur depot. That is Mihan. So we are having a station near that is Kapri, and that area is called Mihan. So our depot is also called Mihan. We are having another depot at a place called Hingna. So that depot has got some 21-acre land here, and the other place also 24-acre land. And we are having stabling lines, inspection lines, repair bay lines, auxiliary repair shop, engineering trainee workshop, unit workshop, cleaning plant, biodigesters, test track. All these facilities are there. This is a view of that depot facilities. Similarly for the Hingna depot. And this is another view of that facility there. And now we are nearing the completion of our phase 1 project, which is of about 39 kilometers and 37 stations. And we are expecting the extension of this project with a phase 2 of length of 43.8 kilometers and another 32 stations, wherein our corridors will be extended to a industrial area called Butibori and the north side Kanan, like that. So this is the end of my presentation.